Hi everyone, this is topic 5.1 reaction rates, and this is taken from AP Chemistry College Board. So in this topic I'll be talking about that what is the meaning of the reaction rate and what are the factors which affect the reaction rates. So let's start. The first thing is, what is the meaning of rate of reaction or reaction rates? The rate of a chemical reaction is the speed at which the reaction occurs. Now, whenever we are talking about rate is basically what's changing with respect to time. So this is the same thing, that the rate of a reaction is the speed at which the reaction occurs. We might be measuring the speed at which the reactants are used up, or we might measure that at what speed the products are produced. For example, let's see this general equation that 2a plus b gives c plus 3d, where 2 and 3 are the coefficients of A and D respectively, and the A and B are the reactants and C and D are the products. Now let's see how can we actually calculate the rate of this reaction. Now, as I told you already, that the rate is basically something changing with respect to time. So here we can either see that how the reactants are used up with respect to time. So for that we can calculate it as minus half delta A by delta T. Now what is the minus half? Minus half is because of this coefficient 2. As the coefficient is 2, so that's why we have put 1 over 2, and minus sign tells you that the reactant is basically used up. That's why we have put this minus sign. And delta is changing in the concentration of A, and delta T is the change in time. Similarly, for B, we can write that minus delta B over delta T. As for B, the coefficient is 1, so that's why it is written as minus delta B over delta T. And then let's come towards the products. Now, for products, as the products are produced, so there is no negative sign here, and that's why the rate can be written as delta C over delta T, and that can also be equal to 1 over 3 delta D over delta T, where 3 is again the coefficient of D. That's why we have put 1 over 3. So you just need to keep in mind that if we are talking in context with the reactant, you have to put a negative sign, and if there is any coefficient, you have to put it in the denominator. And rate can be calculated from any of these. All these will be equal because the reactants are being consumed. So as soon as the reactant will be consumed, the product will be formed. So that's why all the rates are considered as equal. Now these square brackets are the concentration, so you have to put the concentration value in these delta A, delta B, delta C or delta D. Now the rate can be measured by many methods. The first one is, if you see the change in the mass of reactant or product, you can calculate the rate from there, or you can see the change in the pH, change in conductivity, change in the color, change in the temperature, production of a gas. So all these things can be measured, and from there you can basically see that how the rate of the reaction is changing. For example, let's see the change in color. There is a reaction in which the reactants have a different color and the products have different color. So you can see that how much time is it taking to change the color, and from there you can see that how much is the rate of that reaction. Similarly, production of a gas can also be considered. In a reaction, when the gas is produced, you need to collect the gas, and based on the volume of the gas produced, you can basically calculate the rate of a reaction. Now, what are the factors which affect the rate of the reaction? The first thing is, we need to know collision theory. I'm only telling you the main points about this theory, but we'll be talking about this in the coming topics also. So collision theory, basically it is about how the reactant particles are colliding to form the products. Now, for a reaction to happen, the reactant particles need to collide, and there are some things which need to be in that particles for converting into the product. The first thing is, they should be having the correct orientation. The correct orientation means that if they are colliding like this, then only the reaction can happen. If the particles are in this orientation, then the reaction will not happen. So this is the first thing that we need to keep in mind, that the particles should need to be in a correct orientation to convert into product. The second thing is they should be having a sufficient energy, and this energy is called the activation energy. Until the reactant particles don't have this activation energy, there is, even if they are colliding in a correct orientation, there will be no reaction. So these two factors should be there to have a reaction. Now, apart from these two factors, that is activation energy and the correct orientation, there are some factors which actually affect the frequency of collisions. First factor is concentration of reactants. Now, in this first conical, you can see that there are less particles, and as we are increasing the concentration in the same volume, the number of particles is increasing. Now, consider a room in which there are less people and another room where there are more people. Now think of if those people will start moving randomly. Now you can imagine that when there are more people in a room who are moving randomly, there will be more collisions with each other. The same is the case here, that as we are increasing the concentration reactants, the frequency of the collisions will increase, and that's why the rate of reaction will also increase. Now, another factor is the temperature of reaction. Suppose you are doing reaction at 20 degrees Celsius and the same reaction you are doing at 40 degrees Celsius. Now, as the temperature of the reaction will increase, the kinetic energy of the particles will also be more. That is, in the case of the reaction happening at 40 degrees Celsius, the kinetic energy of the particles will be more, and when the kinetic energy of the particles will be more, they will be moving more randomly, and that's why there will be increase in the frequency of the collisions, and that's why the rate of reaction will also increase. The third factor is the surface area of the reactants. Now, suppose you have a big lump of the reactant. Now, when you do this reaction, there will be less collision of the particles because they are in the lumps, and there will be less exposed area through which the reaction might happen. But if you make this lump into powder, so there will be smaller particles now, and when there are smaller particles, it means that the surface area has increased, there is more exposed area, and that's why the particles collisions will be more successful, and that's where the rate of reaction will be more. So as we increase the surface area of the reactants, the rate of the reaction also increases. Another factor is the pressure of the reaction. Now this pressure of the reaction is kind of similar to that of the concentration, but concentration we normally take for the liquids and the pressure we consider for the gases. Now if you have this kind of cylinder in which the pressure is less, it means that the particles are more apart from each other, but when you are increasing the pressure, the particles have come closer to each other, and further if you are increasing the pressure, the particles are further closer to each other. Now when they are further closer to each other, it means that there will be more collisions, and that's where the rate of the reaction will also increase. So if we increase the pressure of the reaction, the rate of reaction increases. Now the last factor is the catalyst. Now what is a catalyst? The catalyst is something which increases the rate of the reaction by lowering the activation energy. Now I told you initially that there are two things which affect the rate of reaction, that is the activation energy and the correct orientation. Now this catalyst is basically affecting the activation energy. It is lowering the activation energy, and when the activation energy of the reaction is lowered, it means that the particle collisions will need now less energy to have a reaction to occur, and that's where the rate of the reaction will increase. So this was all about what is the rate of the reaction, how can we actually measure the rate of the reaction, and what are the factors which affect the rate of the reaction. With this, we finished this topic. I hope you understood the topic. If you like the video, please Subscribe to my channel Long Ada and press the bell icon.